Okay, on number 5, we've got find the value for k for which the line 2y equals x plus k forms a tangent to the curve y squared equals 2x. So you notice we've got two equations. We're probably going to be solving this simultaneously. And the word tangent, well, either we're doing derivatives with tangents, or we can talk about quadratics with tangents. And you'll notice this is going to end up being a quadratic. So we're going to use the discriminant, because the discriminant equals 0 when the line and the curve are tangent. So I go ahead and I make them, I get the one x by itself, and then I substitute that back in. So now it's going to be y squared is equal to 2 times 2y minus k. And then all I got to do is simplify by doing distribution and then get everything on one side, make it equal to 0. So now you notice I couldn't solve it because I got two variables, but I can use discriminant b squared minus 4ac. So I go ahead and plug that in, and then I'm going to make it equal to 0. Now, not because it was equal to 0 before, but because discriminant is equal to 0 when it's tangent. And then when I get k by itself, I find out that it equals 2. All right. In the next one, it's the same kind of question. It's tangent. There's two different equations. I go ahead and get this y by itself and then substitute into the other. And what's going to happen is you'll notice I get another quadratic. So all I've got to do now is x times x minus 2x equal 8. And then I've got kx minus 2x squared equals 8. I get it all on one side. And I've got an a, b, and a c for my discriminant. And once again, I'm talking about tangent. And so the discriminant's going to have to equal 0. It's got nothing to do with the fact that it was equal to 0 before. It's because the tangent is going to be equal to 0 with the discriminant. So all I got to do now is solve this. And then I'm going to find out that k is plus or minus 8. Now for number 7, I've got a function. Now remember, functions are just x inputs and then f of x outputs. This is a weird one because you'll notice the original function, it's got ax squared or a squared and x. It's got a's, x's, b's, and technically y's. Now you notice below we've got two other equations with inputs listed. If I put in a -2, this is what's going to come out. So here's what we're going to have to do. We take the -2 and plug them back into the original. Now you may be wondering, why would you do that? We already know what f of -2 is. Well, see, the problem is, look at this. We've got we don't know what the output is when you put a -2 in, and we don't know what a and b is. There's three things I don't know. And when I put this in here, you'll notice that I'm going to get 4a squared, but it's not going to be the same as what they told me it was when it's f -2. I get something a little bit different. So now these two outputs would be the same, and so I can take each of the others and make them equal to each other. And now I can solve and find out what a and b are. See, in the original, I've got three things I don't know, and so I've got to get rid of one of those things. And by doing this substitution, I'm going to be able to do that. I have the same problem here with the f -3. They tell me what's going to come out, but when I put in my -3 into the original, I get something that looks different than theirs does. But the fact is, f to the f of -3 should equal each other. So all I got to do is make these two guys equal to each other. And when I do that, I'm going to end up with an equation. Now my new equation, like the other one, it's going to have just a's and b's. But at least it's not going to have three variables like it did before. So now I can take and solve these two simultaneously. And we can take a look at this. You'll notice both of them have a 4b. So what I'm thinking is I'm going to get that 4b by itself, and then replace the 4b with 8 minus 2a. And see, now I don't have any b's at all. I've got our a's. So all I've got to do is solve it. I end up with a quadratic, and it's got a number in front of the a for a. So I use the x factor to solve it. And when I do that, I'm going to find out that it's going to be equal, well, my two numbers are going to be 2 over 1 and negative 3 over 2. Keep in mind, those are the opposites of what A are equal to. So A is actually equal to negative 2, and A is equal to 1.5. And now that I know what A are in two different situations, then I've got to take them and substitute them back in to find out what B is. Well, here I almost have B by itself, so I go ahead and get it by itself, and now all I do is substitute in the negative 2, and I find out that A is equal to 3. And then when I do that for my other A, I got that. Now keep in mind, when you're answering this question, you've kind of be clear. This A goes with this B, and this A goes in this B. All right, now part 2. Now they're telling me what A and B are. And so if, say for instance, you're totally clueless about part 1, you could still do part 2. Because all I'm going to do now is substitute in my A's and B's that I know about into the original. And it gives me this quadratic, and they give me a domain. And then they want me to find the inverse. And like I said, they always want you to find the inverse of a quadratic, it seems. So one of the first things that I'm going to do is switch the variables back and forth. And now I'll get a little sketch of it. And when I take a look and find the vertex, so that's going to, using negative b over 2a, I'm going to find out that the vertex is going to have an x of 1/2. And then when I plug it back in, I'll find out that it's got a y of negative 13/4. Or I could also refer to it as 0.5 and negative 3.25. Anyway, now that I got a vertex, I could rewrite this in vertex form like we did earlier. All I got to do is the opposite of the x part of the vertex, put that inside, and then put the y part at the end. And now if I'm going to find the inverse, I'm going to add 3.25 to both sides, and then I'm going to square root both sides. And I'm going to end up with plus or minus x plus 3.25 is equal to y minus 0.5. And then I'm going to add the 0.5 on both sides. And so you'll have the same problem that we had earlier where it can't be plus or minus because then it's not going to be a function. So we've got to figure out which one it is. And again, the pattern we noticed before, if the parabola opens up and our domain is less than the vertex, well then typically the answer is going to be minus. But let's go ahead and put in a point from the original and then take its inverse. If I put a 0 in there that's in the original, then negative 3 comes out. And then when I try negative 3, 0, well, I find out that the only way that's going to work is if it's going to be negative. So now I rewrite it in the right notation using f negative 1. It's 0.5 minus x plus 3.25. Now, they want to know about the domain, and remember, all we got to do to figure out the domain is figure out the range of the original. Since we already figured out the vertex, and again, it opens up, I know that the range of the original is everything greater than negative 3.25. So that means the domain of my inverse is going to be, x has got to be greater than 3.25, which makes sense because if you look at the radical, if there's anything smaller, then it would be negative under the radical. Okay, thanks for watching. Hope that helped.